what we did well, what we didn't necessarily do well, and hopefully we can all learn something from it. So first, maybe just a very quick word about myself. My name is Maxime Klaus. I'm a software and machine learning engineer, and I'm very enthusiastic about technology in general. I have a background in cybersecurity and cryptography. Then I worked for a couple of years in the security space. Then I moved to more traditional web and backend development before I transitioned to writing data pipelines and machine learning solutions. You can find me on social media, GitHub. There's not much on the GitHub, and email if you guys want to reach out. So I'm the CTO and co-founder of DeepGreen. DeepGreen is an AI company focused on the agriculture industry. We develop AI-enabled cameras that monitor plants and try to detect automatically pests and diseases, so farmers can pinpoint the application of pesticides, so you can save money instead of applying on an entire field. And that also reduces the pesticide use for the end user, so whatever we are eating, basically. Our technology stack is mostly based on Java and Python for the backend part, React for the front end. We use TensorFlow very heavily. I'm going to try not to be too technical, guys. That's just that. We use a little bit of Keras for those of you who know it. And for the infrastructure part, we deploy everything on Google Cloud, and we use Spring Cloud to do the heavy lifting for us for our microservice infrastructure architecture. And so, maybe an interesting fact about DeepGreen, we work mostly, but not only, with customers in the legal cannabis industry. I have to say it's legal. The reason is very simple, it's that a cannabis plant today is worth approximately $500, so it makes it worthwhile for these guys to buy our technology, and it's a great way for us to develop it and try to make it scalable to the general food industry. But we do work with food as well. So I chose, we have only a couple of minutes together, so I chose 4 topics that I think are important and were important for me in the past 2 years. I'm not going to have time to dig very deep on this subject, so by all means, well, we'll have a Q&A after, but if you guys want to dig deeper, we can just take a few minutes to chat after the talk. So let's start with data. Acquiring data is hard, and what we found that the hard way. So even if it doesn't look hard, in our case, I promise you, standing for 6 hours in a cannabis cultivation with your laptop on your arm trying to label data is not funny at all. And you smell really bad at the end of the day. What we found out the hard way was that acquiring data, any data, was fairly easy for us. We found customers very easily in the first couple of months of the life cycle of the company. But all the customers we found had no problems whatsoever. They were pretty happy to open their cultivation because they were kind of showing off in a way that they were good growers. But valuable data, in our case, is disease data. We want, the bad growers, basically, the ones that have problems and that need our help. But these guys were kind of hiding. I don't know if it's shame or something, but it took us almost a year, 11 months exactly, to find our first customer that had a really terrible grow. It was really terrible, and from that day, our accuracy and everything just skyrocketed. So we definitely didn't expect to spend almost a year finding these guys, and 1 year in the life of a young startup is a lot of time, I promise you. And what's worse is preparing the data is even harder. Maybe I should speak closer. Preparing the data is even closer. So you've seen that in the previous picture I was in the cultivation with my laptop on my arm, basically. Because the patterns that we identify are so subtle, and we do object detection, by the way, for those of you who know what that is. Basically, we try to draw boxes on the stuff that we detect. And because those patterns are so subtle and we cannot afford to make mistakes, we need to actually label data, run through the data on-site directly. And that's a lot more expensive and a lot more time-consuming than we ever expected it to be. We expected that we'd just take a picture and just draw boxes on it, but that cannot be done that way, unfortunately for us. So yeah, expect some surprises on the data side, definitely. Another one that was a really tough one for us was tasking. I'm sure it's always going to be a problem, it's always going to be challenging. So here's kind of a joke, a user story. As a user, I want to know with 100% certainty, as if this was possible, but if my plant has powder mildew, which is some sort of mold. Maybe your PM is going to, tell you, okay, that sounds complicated, make that 8 points, but it doesn't work that way with machine learning. So really, when you do machine learning, the first thing you want to try to do as soon as possible, and we weren't very good with that actually, is define the proper metrics that have meaning in your case. And that could be accuracy, that's the one everybody knows. That could be, in our case, for object detection, MAP, precision and recall, true positive, cost. If it costs you $10 to run one inference on your model, an inference is basically a prediction on machine learning model. If it costs you $10 per prediction, then maybe you don't have a business, probably. So cost is also a very important one. And make sure that you know what is the minimum requirement that you want for your MVP. And most importantly, make sure that your business understands them. So the CEO, the salespeople, the biz dev, they are the guys speaking with your customers. And in our case, for example, if they speak about accuracy, our customers speak about accuracy, but it doesn't make sense for us. Accuracy doesn't have any meaning for object detection, for the type of problem that we handle. So we need to make sure that the business knows how to explain, how to understand and explain recall, precision. Like we try not to miss anything that matters, but we have false positives all the time. Does that matter to our customers or not? That kind of things. So that's very, very important. And go fast. For us, 2-week sprints were way too slow. Too long. So we decided to move to 1-week sprints after learning the hard way that, 2 weeks was just, we were making way too many mistakes. And the reason for that is because when you're doing machine learning, you're gonna base a lot of things on assumptions. If I change my data, my model is gonna get better. Well, maybe, but you need to train and verify that first. And so things are going to change. You're going to make wrong assumptions all the time, and your scope is going to change because of this. And so basically, the faster you can react, the better. So what I mean by that is a couple examples of what I mean by assumptions. You want to change the way you label your data because you think your accuracy is going to go up. That's an assumption. You're not 100% sure that. You might be 99% sure, but not 100%. Your network design, if I remove some layers in my network, for example, and that's specifically for deep learning, it's going to cost me less and perform the same. Well, again, it's an assumption. Hyperparameter, do I learn faster if I up my learning rate? Again, you need to train, and pretty much anything that results in a training is somehow based on an assumption at some point. So anything that's based on a training, you don't want to base an assumption on another assumption, basically. Try to test as many things as possible at the same time. And so we try to mix this with what I call fixed workloads. I don't know a better word for it, which is basically all your engineering, classic engineering tasks. So you need to write some Python code for better data exploration, some visualization, something like that. Develop a new model, task automation, that kind of things. Any engineering things that can be easily estimated, basically. And so, when you start working on machine learning projects, it's never really done. So plan to spend probably some resources pretty much forever, or for the life cycle of your product, because you're going to have to keep improving on your model. And you can automate some of these tasks. You can automate retraining, that kind of things. But if you do supervised learning, for example, you're always going to have to label something, and that incurs some cost. In any case, you will always have to maintain some part of your solution. So that's a cost that needs to be taken into account. Technology, I can speak about that for hours, so I'm going to try to be quick. I'm not sure, 10 minutes. It's most likely going to be more expensive than you think. It was actually for us. I'm going to speak specifically about TensorFlow, but I'm pretty sure that applies also to Caffe, PyTorch, and other frameworks as well. Documentations are usually outdated. New releases bring breaking changes. And an example, for example, if you want to install TensorFlow with acceleration support, so GPU support, for those of you who know what I'm talking about. You will need to follow instructions from 5 different sources. You will need to follow instructions from the TensorFlow website, the Blazor website, the NVIDIA website for CUDA, the NVIDIA website for CUDNN. It's 2 different parts. That's the official one. It's not going to work. Then you're going to have to rely on the 5th one, Stack Overflow, to try to find out what the problem is. And that's definitely also a cost when you don't have experience with it. And what's worse is it changes very, very fast. So we started at DeepBrain with version 0.12 of TensorFlow in 2016. So that was kind of an alpha version. In 2017, they released 5 major versions, and in 2018, 8 versions. And they still have a month to maybe deploy the 9th one. So it's going very, very quickly. It's accelerating. I'm scared for next year. For example, we're still running version 1.8 in production just because we didn't have time to update. We're probably going to update in the next few days, but every time a new version is released, it's costly to actually update. And you might have breaking changes, which means some of your older models might not work anymore, and that kind of things. Good surprises always. So all in all, for technology, just remember that it's kind of a young and kind of immature community. There's no really any engineering discipline. Even Google, Facebook, they don't have that much engineering discipline when it comes to machine learning. And so one thing we did really well at DeepBrain, I think, is that we try to leverage PaaS as much as possible from the beginning. Now we were using ML Engine. I'm not too familiar with AWS and Azure, but I'm sure they have something similar to ML Engine. ML Engine allows you basically to, thank you, to automate the creation of a cluster for training, or to automatically deploy your machine learning models to a production environment. You get an API to call it. It's your model. You can use your own model code, right? So it's not like I don't know the IBM solution. It's really pretty cool. There are trade-offs, of course. You cannot have a GPU for inference, for example. So in our case, because we handle very large pictures, inference time was 45 seconds. That's not okay for a business, but it was definitely okay for MVP. And that was the difference between us getting funding and getting into an accelerator, and us, me not being here today, basically. So that was definitely a good choice, and consider it. If you can speed up things for you, and if you're early stage, that's definitely something to consider. And so the last point is the team. I'm trying to go fast on this one. It really depends on you, basically. If you speak to several people, you're going to get several definitions for what a data scientist is, or data analyst, etc. I think there are probably as many definitions as there are data scientists in the world. So it really depends on you, on your size. We can speak very, very quickly about the roles. Data scientists and analysts, they're kind of used interchangeably. PhD or not, I don't really think it matters. I think what matters most in that case, or what mattered most for us, was to have somebody we can trust with our data, because that's going to be the most important point in developing your supervised models. I'm speaking about supervised machine learning here. Software data machine learning engineer, I think it doesn't really matter. I was talking with one of the head of data science at Google a couple of weeks ago, and he was telling us that for him, the most valuable resource is really a software engineer that can write a good data model and design a good solution around the machine learning solution that they're trying to develop. Machine learning itself, I mean TensorFlow at least, unless you're working in a research team, you're dealing with plottable files, basically. And of course you're developing models, but it's not like black magic or anything. But I mean, if you're a software engineer and trying to work in the AI space, just be a good software engineer, basically, and you're going to find a job in AI for sure. And data collector, I made that one up. As you saw, we need someone full-time that we didn't expect at all to actually collect data on-site in the cultivations. That's a cost that we would never have imagined. And the point of this is that you're probably going to have things that are going to be specific to your problem, and you can't really rely on what other people are saying, basically. And that brings me today. So in short, versatile people. If you can find someone who can do all of that, just hire that person as soon as possible. So to conclude, you might expect basically a lot of time refining your data, a lot of time looking for the right people, a lot of time dealing with problems in a young industry, basically, from the community. Like many mistakes when tasking and trying to estimate things, and sprint going awfully wrong sometimes. But in the end, I think it's all worth it because you're going to have fun. We're solving problems that nobody solved before us. So yeah, for me at least, it has been a terrific experience working in AI, and I hope it is for all of you guys. Thank you very much. I'm going to listen to your questions.
Thank you. So I would like you to give massive Ohata by asking the question, please.
Thank you, Dan.
Anyone, you have the question? Ask you. I still see no hand.
You don't have to.
I saw 3 hands.
Okay.
How long does it take for you to build an AI model? I mean, how long does it take for you to learn a pattern of the AI model?
So do you mean to learn a new disease, for example, a new pattern that the model needs to detect?
Yeah.
So that really depends how often we see that pattern in the real world. So for example, for the very first pattern we detected, it took us probably around 12 months because it took us 11 months to find the first example of powdery mildew in that case. So before that, we had a solution that was half working, more or less, which allowed us to get funding luckily, and that was basically based on public images or whatever we could, take with our phones when we would go to cultivations. But it was really not even halfway there. Once we started getting data, valuable data flowing in, everything was changed, basically. Now, if we get new disease, it can take maybe 2 to 3 weeks, the time for labeling the data and just develop a model that is ready for production, basically. Thanks for the question.
Can I take the lady?
My question is, what skills does someone who doesn't know so much about AI to do this type of thing that you're doing? Like, do they need? What type of skills do they need?
So you mean technically?
Technically.
I would summarize it as problem solving. So for what we're doing, for example, there is some custom stuff that we're doing on our models, but really you can find very good off-the-shelf solutions on which you can just modify a few things and get something running very, very quickly. Then it's all about, I would say, reading a lot about how to basically prepare data, that kind of things. You probably need to learn Python. Everything is, well, not everything, but there are people who use R in the room maybe, but really the language that is most used right now is Python, so you probably need to know that. And then I guess it's, if you want to build the whole company around it, you need to know architecture and that kind of thing. So AI is really just a small part of actually solving a business problem. Yeah.
Because I see a lot of like picture processing, like noticing stuff, like digitally and things like that.
Yeah, so if you want to do that on your laptop, for example, I mean, you could probably get up and running with just off-the-shelf solutions without writing a single line of code, I think. So that's how easy it can be. Now, if you want to have a business, that's different because, of course, you're going to have to build a lot of things around it, and you cannot just run around with your laptop, right, for providing your solution. So then it's pretty much all software engineering skills that are going to be required in a company, so architecture, software design, writing APIs, that kind of things. In our case, it's even embedded software, because we need to develop our own cameras. So I don't know how to answer that question without spending an hour on it, to be honest. But yeah, you can get up and running without knowing pretty much anything about AI, just being able to prepare your data and follow a few tutorials.
Makes sense. Thanks.
Thank you. I saw two hands before. Can you please raise your hand again?
Yeah, here.
Wait a minute.
Okay. Could you tell me your company optimization for using TensorFlow? Yes, process data cost.
So
Using cost?
Yeah, so you want to speak about the cost of one inference, for example? Running one image through the model?
Yes.
Okay, so that's around 0.1 cent. So 0.1 cent is approximately the cost, what it costs us to run one image through our model. And that includes, if I include network cost, etc., and all the infrastructure that is around it, that's 0.2 cents. But the GPU cost, the VM that is running the inference, costs us approximately 0.1 cent per picture. Now, if we're speaking about training, well, you just multiply that by the size of the data set and the number of epochs that you're running your training on, and you get approximately the cost of your training. Plus the cost of evaluating the performance of your model, etc. You can add maybe 15% for that. And you get approximately the cost.
Okay.
The lady first. Okay. So as a beginner of studying AIs, I have two questions. The first one is how much the data do you collect enough to have like approximately accurate result? And the second one, there must be the trade-off between the real-time data and the cost of infrastructure, as you mentioned. So how you moderate maybe offline and online data processing to have like optimized result. Okay.
So, wait, could you repeat the first question?
How large sample data?
So it really depends what kind of technology you're using. For us, we can get up and running and have a very reasonable model with just a couple hundred pictures. So under 500 pictures can be okay for us. And that's because we're using something that is called transfer learning. Now, it's not always applicable. So we can use that because we're using, maybe some of you know about RetinaNet. We use a variant of RetinaNet. But basically, we can reuse models that were trained by, in that case, it was probably Facebook for the one we're using, and just tweak that model to solve our specific problem. And you need only a few pictures for that. If you were to train a model from scratch, then you probably need somewhere in the likes of 1 million to 10 million pictures, which is a lot for most companies. So as a startup, it's just not doable. But you can use public data sets, for example. You can do your own transfer learning. So you can create your own model. Just take ImageNet, which is a huge image data set. Train your model on that, and that's really expensive. So you need to be ready for that. It's going to take a long time. And then retrain that model again with your smaller data set. So that answered the first question. And I forgot the second question now.
All right, just about like the trade-off between real-time data and the cost of the infrastructure. So how you moderate it to have the like better result compared with the cost?
So the costs come from a number of places, and most of them are fixed. So, for example, I mean, you have obviously the cost of maintaining your infrastructure, so your virtual machines, etc., your APIs. In our case, we have an API gateway, that kind of thing. Right? Unless you have very large traffic, you need that many of the servers. So you could consider it almost like a fixed cost that is not related to your data coming in. One of the costs, though, that is pretty high actually is the cost of storing that data, and you're going to need to store this for a long time. So I would say probably one of the ways we reduce that cost of storage is actually we know that there is valuable data and there is data that is less valuable. The data that is less valuable we almost never use, and that's probably 95% of all our data, to be honest. So that data we can just put on some cold storages that are very, very low cost, but they are very expensive. That's a Google solution. I'm sure AWS has something similar. Glacier, I think it's called. Well, if you access that data that is not supposed to be accessed, it costs you a lot. But if you don't access it, it costs you almost nothing. So for data that is not variable, you should definitely use something like that. And for data that you reuse all the time for training your models, of course you want a storage where you can access your data as much as you want without any incurred cost.
Okay, thank you.
You're welcome.
Okay, so I know that in your team, currently you don't have a product manager or 100% product person, right? So I'm interested to hear how you make product decisions, right? How do you prioritize features? How do you take UX decisions? And how do you make sure that what you're building is actually bringing value to the users?
So we spend a lot of time speaking with our customers. And as you saw, we meet with them very, very often, pretty much. But it's definitely tough to not have someone full-time to actually manage product decisions and, it might be something stupid, but just wireframe, for example, is something that's painful for us, just because we don't have that kind of skills. So we have someone in our team that we call our Swiss Army knife, who can do a little bit of everything. And every time we have something to do that we don't know how to do, it's pretty much relying on him to do the job. If that answers the questions. But yeah, it's have a product person on board, it helps, definitely.
Thank you.
Thank you, Massive.
Thank you.
Great job.